Hi folks, we're going to take a look at a couple of quick examples on using the product rule. Okay, so take a look at this first example. We have h at x, and we see that it's written as the product of these two polynomials, and we want to find the derivative of that function. Okay, keep in mind that there is another alternative. We could expand these two polynomials and then solve using our other derivative rules. Okay, but here I want to focus in on the product rule. So the first thing I'll do is I'll just remind myself of what the product rule says. So if I've got the product of two functions and I'm taking the derivative of that combined function, okay, that can be found by finding the derivative of the first, multiplying it by the second function, and then adding to that the first function multiplied by the derivative of the second function. Okay, so make sure you find some good memory trick for remembering this formula here. Okay, as it is a combination of the original functions and the derivatives. Okay, so let's go ahead and actually apply this to finding h prime at x. Okay, so you'll see here that I'm going to try to write less and less, because a lot of these derivatives, once I know the rules, I can take quite quickly. Okay, so first thing I'll do now is find the derivative of this first function. So I'll label that first bracket as my function f at x, and this second function will be g at x. Okay, so if I take the derivative of the first, okay, I've got the subtraction, so I can split these up. I'm first going to take the derivative of x cubed. So applying my power rule, that's just 3 times x. Okay, so the exponent now becomes my coefficient, and the exponent goes down by 1. So 3x squared minus, similar here, 2x to the 1, which is just 2x. Okay, so this is that first part, the derivative of my first function, and I'm just multiplying it to the second function. Okay, so 2x to the fourth minus 3x squared minus 4. Okay, so now we've completed the first half of the derivative. Now let's finish off. So now we take the second function, so that remains unchanged, x cubed minus x squared, and now the derivative of the second function. Okay, so 2 times the derivative of x to the fourth. Okay, so x to the fourth will be 4x cubed. So 4 times 2 is 8. So you see how I try to solve these all in one step if I can. Okay, then times x cubed. Okay, you may find that you need to write this in more than one step, and if you do, that's no problem. So here minus, okay, 2 comes down, so 3 times 2 is 6, and so the remaining exponent is just 2 minus 1, 1, so 6x. And then minus the derivative of this constant 4, and the derivative of any constant is just 0. Okay, and there you have it. Here's our derivative. Okay, now in several questions on the test, I'm going to ask you not to simplify these answers. So this is what I would expect your answer to look like, just applying the product rule on the given function. Okay, if you did want a simplified answer, of course what you'd have to do is multiply everything out, both of these, and then bring together like terms. I'm not going to do that now, because for this test, most of these types of questions with this complexity, you'll probably be asked not to simplify. So the important thing is how to apply the product rule. Okay, let's go down and do this question here. Okay, same thing. I have this derivative of a product. So again, I think of this as being f at x. This as being g at x. Okay, now again, you'll probably hopefully get to the point where you don't need to convert this into exponent form. But I suspect at the beginning that might be a good idea. So the first thing I'll do is I'll just convert these expressions into exponent form. So here we have x. So this square would become our number in the numerator of this rational exponent, and then cube root relates to exponent 1/3. So the end result would be exponent 2/3. And then here 1 minus x to the 1/2. Okay, and now I'm going to apply the product rule to this here. Okay, so again, I'm going to try to do this without writing out the equation. So derivative of the first, so the derivative of this first function. So again, our exponent becomes our coefficient. Okay, and then I subtract 1 from 2/3. So 2/3 minus 1 is just negative 1/3. Okay, times the second function, 1 minus x to the 1/2. Okay, plus the first function, x to the 2/3. Okay, times the derivative of the second function. Okay, so here the second function is x to the 1/2. So, the second function, first the derivative of 1 is 0. Okay, and then minus the derivative of this second part. So again, exponent becomes our coefficient, so that becomes 1/2 x 1/2 minus 1 to the minus 1/2. Oops, there we go. Okay, and this one here, let's just simplify this one here just to see how it goes. Okay, so the first thing I'll have to do is distribute. Okay, so we've got 2/3 x to the minus 1/3 times 1. So 2/3 x to the minus 1/3 times 1 doesn't change, minus 2/3. Okay, and now x to the negative 1/3 times x to the 1/2. Well, we know we have to add these exponents. Okay, so on the side, negative 1/3 plus 1/2. So that's negative 2/6 plus 3/6. Okay, so here we've got our end result of 1/6. Okay, plus here, well, we have x times this here, so it's going to be negative 1/2. Okay, and x to the, well, similarly on the side, I know I have to do 2/3 plus negative 1/2. So 2/3 minus 1/2 when I add these exponents. So here we've got 4/6 minus 3/6. 4 minus 3 is 1. So x to the 1/6. Okay, so looks like we can do a bit of simplifying here. Okay, so I can bring these two terms together since they're like terms. Okay, but I won't bring this one along the way. So let's start by rewriting this here. So in the numerator, the only thing that remains is the 2. And then here we've got 3 in the denominator. And of course this x to the negative 1/3 I'm going to bring down into the denominator to become x to the 1/3. So cube root of x. Okay. Now let's bring together these two fractions. So here we've got negative 2/3 and then we've got minus 1/2. Okay, so this is negative 4/6 minus 3/6, so negative 7/6. And then here, x to the 1/6. Okay, which of course I can now write as 2/3 cube root of x, and this is now minus 7/6, and here this is the 6th root of x. Okay, so again, on a test, I'm most likely going to ask you to stop here for this type of question, just because I'm trying to evaluate the product rule. However, if you did need to actually simplify, this would be the final answer I'd expect. Okay, that's it. Thank you very much.